Welcome to today's deep dive. We've been poring over technical spec sheets and engineering white papers for a very specific piece of hardware. It's the DVIGear DVI-2510-AOC. Basically, it's a 10-meter HDMI cable that retails for $325.
Yeah, which is a pretty steep price tag for an HDMI cable.
Right. But our mission today is to figure out why professional environments absolutely require this specific gear instead of, just grabbing a standard cord off a shelf. So for you listening, okay, let's unpack this. Pushing uncompressed 4K video at 60 frames per second demands a massive 18 gigabits per second of bandwidth.
Exactly, and getting 18 gigabits across 10 meters, which is about 32.8 feet, that is where traditional copper just hits a physical wall.
Wow, just 10 meters.
Yeah, just 10 meters. Because it's not just about the sheer volume of data. It's really about electrical resistance. As a copper wire gets longer, it acts like a resistor and a capacitor.
Oh, I see.
So it literally eats the electrical signal. It blurs those sharp square waves of digital data into just this unreadable smeared mess by the time it actually reaches the display.
So it's basically like trying to send rapid-fire Morse code by tapping a hammer on a really long metal pipe. The vibrations just bounce around and get totally muddy.
That is a perfect way to put it, yeah.
So to push that much clean data over that distance, you can't just use thicker copper. You have to change the medium entirely.
Precisely. And that's why this cable bypasses the electrical bottleneck entirely by using an active optical cable, or AOC, design. Inside the actual connector itself is a transmitter module using VCSELs.
VCSELs, wait, what are those?
They're essentially microscopic lasers. They pulse billions of times a second to instantly translate the incoming electrical voltage into light.
That is wild. And then that light shoots down 4 polyfluorinated optical fibers, the POF, right, at an 850 nanometer wavelength.
Right, exactly.
So instead of muddy vibrations on a metal pipe, it's like flashing a strobe light in a perfect vacuum. The signal stays perfectly crisp no matter the distance. Plus, it's totally immune to the electromagnetic interference you get in professional AV setups.
It really is. And what's fascinating here is the sheer efficiency of that mechanism. Despite converting electricity to microscopic laser pulses and then, translating it back to electricity using optical receivers at the other end, the cable draws less than 0.235 watts.
Wait, really? Less than a quarter of a watt?
Yeah. It just pulls that directly from the source device's HDMI port, so there's absolutely no external power brick needed.
Wow. Okay, but wait, I'm looking at the engineering schematic right now. Here's where it gets really interesting.
Okay, what do you see?
Well, if this is an optical cable running entirely on light, why are there 6 copper wires explicitly listed inside the casing alongside those 4 optical fibers? Doesn't adding copper defeat the whole purpose of a fiber optic cable?
You'd think so, wouldn't you? But that is actually the hybrid genius of the design. See, the fiber optics are strictly doing the heavy lifting for the 4K video data.
Okay.
But HDMI requires a two-way conversation just to even turn on. So those copper wires are handling the electrical power and the DDC, which is the display data channel.
Ah, right. So the DDC is what handles the digital handshakes.
Yes, exactly. It manages the ED.
Which is how the display tells the source what resolution it can handle, right?
Yep. That and the HDCP 1.4 and 2.2 copyright protection. Those protocols operate at a much lower bandwidth, so copper handles them perfectly fine over 10 meters. Without those physical copper wires instantly confirming the handshakes, your screen would honestly just stay black.
That makes total sense. But putting both fiber and copper into one jacket, that usually makes a cable super brittle.
Oh, definitely.
But the physical durability here is wild. It maintains a tiny 2-millimeter bend radius for tight corners, yet it somehow withstands 500 newtons of crush resistance.
And over 200 newtons of pulling tension, too.
Right, and the outer jacket is even plenum rated. So it uses specially formulated fire-safe plastics, so installers can legally run it through building drop ceilings without violating fire codes.
It's just built to survive the harsh reality of professional installations, all while delivering completely flawless data.
So what does this all mean? Well, for you, the listener, while you probably don't need a $325 cable for the TV in your living room, this hybrid technology is the invisible backbone of modern infrastructure.
Yeah. It really is.
It's what ensures zero-interference video feeds in massive arenas, corporate boardrooms, and broadcast studios.
And if we connect this to the bigger picture, hybrid cables perfectly bridge the gap between traditional copper infrastructure and the high-speed optical future.
Right.
They solve the immediate bandwidth crisis of 4K and 8K without, forcing the entire industry to invent a completely new type of port for all our devices.
That is a huge point, but that does leave you wondering about the absolute limits of physical media.
For sure.
Because as our display resolutions eventually push past 8K, 16K, and beyond, will we hit a data threshold where even hybrid physical cables become obsolete?
That's a real possibility.
Right. At some point, the data demands will just become so massive that we might have to abandon physical tethers entirely, which could force a fully wireless revolution. Something for you to think about the next time you plug in a screen.